Hello, my name is John Kim. I am the project manager for Team HITALIC, and I'll be presenting our final presentation. Since we already had a number of presentations on the project during the semester, I'm just going to briefly summarize the project goals, how we approached various problems, and the progresses made so far, and then I'm going to move on to the actual demonstration of our final solution. So we've been working with Emory Interventional Radiology team to help them optimize the scheduling workflow. For inpatients, the order for the procedures are entered by physicians using Cerner system, and they become ORM HS7 messages, and they go into airflow. For outpatients, appointments are made in Cerner system, and they become SIU HS7 messages, and they feed into airflow. So Cerner system is the actual EHR system, and airflow is used to process the patient flow for the day and manage resources and rooms in real time. The problem here is that even though there is an integration between the two systems, the staff still needs to assign the rooms and resources manually each morning. Because this relies on human decisions, mistakes can happen, and more importantly, the result might not be optimal or efficient. After a number of discussions with the stakeholders from Emory, we proposed to build a web-based solution that sits between Cerner and Airflow. It will receive ORM and SIU messages just like Airflow, but it will then process them and automatically assign rooms and resources for each procedure based on the rules predefined by the user. Finally, the optimal schedule will then feed into Airflow, thus eliminating the manual work done by the staff. Unfortunately, because of the constraints of the given time and also because we couldn't get access to any of their systems, we had to revise our goals. So here is more achievable goal for the semester. So as you can see, we created a mock Cerner system that can generate sample OLM and SIU messages on demand. Then our solution will take these messages and run the scheduling algorithm, then finally display the optimal schedule. Then the staff will just need to enter them as is in Airflow. This is still a manual work, but at least they don't have to use human heuristics, and that will make a huge difference in efficiency. So here are some user interface prototypes we created. The first prototype is a simple login screen. And this is the schedules page where the users can see the optimal schedules for the day for each room. And finally, this is the details page where one can see the details of the schedule and possibly modify some information. Now, without going too much in details, I'd like to briefly go over our technology stack. Our database is MongoDB and it is hosted on MLab with a free account. Our backend API server is using the loopback framework and it is deployed with AWS Elastic Beanstalk, and therefore it has a potential to scale depending on the needs. Then we have the front end done in Angular 2 and it is hosted on AWS S3 bucket, and it is totally separate from our backend. As you can see, we created two Docker containers, one for the front end and another for backend. We did not create a container for our database layer as we wanted to have one master database at this point to control all data, as a lot of changes will still come later. Before I discuss the team member responsibilities, I'd like to mention that one of our teammates dropped a class, so we had only 3 people in the team. Anyways, here is how we divide up the work. So as a project manager, I took care of all communications with our stakeholders. I also set up the infrastructure on Amazon Web Services for the deployment and designed the data models and HL7 mock messages for the project. Finally, I was responsible for most of the official documentations like requirements analysis and the design documentations. Mohammed was focusing on analyzing the predefined rule set and was responsible for the scheduling algorithm, which is actually the heart of our project. Finally, Stefan was working as our user interface designer, and he also implemented most of the user interface for the project. So here is our Gantt chart for the semester, and I'm just going to go over the major milestones and the issues we had. So we had our first meeting with our stakeholders on October 16th. As you can see here, we had our infrastructure set up on AWS and also had our empty backend and front end up and running by late October, but we couldn't continue because we did not have much information to proceed until Stefan actually made a visit on November 10th. Then we finally got connected with Starla, who acted as the technical advisor at Emory Healthcare, and we were able to finally create the requirements analysis documentation and get started with the actual development. So as I'm recording this presentation, we are about 90% done with the user interface and about 80% done with the scheduling algorithm. So finally, I'm going to show you the actual application at current state and discuss the items to be done. So before I show you the application itself, I just wanted to show you how our backend is working. So this shows all of our data models that we created according to the design documentation here. So these, if I want to take a look at the list of rooms, these are all the RESTful API available. So let's just do a simple one. We just query this and it returns the list of rooms from the database. And if we take a look at the database itself, this is the room table and it shows all the rooms available, and it matches the list here. So here is the login page. As you can see, you cannot access any other page without authentication. If I put wrong password, it won't give you access, obviously. So I'm gonna put the right password. So it will go to the schedules page. Right now it's empty because we just cleaned the data. First we'll show you the admin page here. So it shows all the data inside our database. So we have 5 rooms available. We have 3 resources. We have 50 procedures. We got this from Dr. Berkey's list. Also we got the rules. It's the detailed rules for each procedure. We have 1 admin and 0 patients at the moment. So here in the mock Cerner system, we can create HS7 messages on demand. So I'm just going to create 3 ORM messages. You can look at the details by clicking here. It has the basic structure of HS7 message. You can also create SIU message. You can specify the exact time and date, and it will create that appointment here. So now we have 4 messages. So I'm gonna create the optimize button. So it creates 4 appointments in the systems. Obviously, we have to tweak a lot of stuff, but you can get the basic idea. So it grabs the messages and it would optimizes them and it puts them into our database for display. So we, as you can see, if we go back to the admin page, it made patients, imported patients here. They are random patients we generated. So yeah, we have a lot to do, but it at least shows the basic workflow in our system. And log out now to complete the demonstration. So in the end, obviously the solution is not usable at this point because it is not connected yet with the production system at Emory Healthcare. But at least I hope it has shown the potential to our stakeholders. Again, this diagram was our original proposed solution. And if correctly implemented with all the access, I see it can really improve the workflow. Also in the future, one could utilize the machine learning techniques so that the users don't even have to create and manage predefined rules, but the system can learn from the past data and create the optimal schedule by itself. Well, that was it. I'd like to thank again to our stakeholders at Emory Healthcare for providing this opportunity. And finally, I'd like to thank our team members and our TA for all of their hard work and support. It was a real pleasure working with all of you. Thank you.